Greetings, guys. Okay, I want to walk through Activity 10, Complex Fractions, which is going to put together everything we've learned about adding, subtracting, multiplying, dividing fractions. So I'm going to use these notes to do it. Now, if you were going to add these fractions, I dare say most of you are probably going to do this. You're probably going to look and say, I'm going to find a common denominator between these two. So you're going to ignore the bottom and just work with the top for a second. And you'll say common denominator is 6. So I'm going to multiply a 2 over 2 here and a 3 over 3 here. Okay, and that will give me on the top, I end up getting 3 times 1 is 3 over 6 plus 2 times 1 is 2 over 6. And so I end up getting 3 plus 2 is 5 over 6. Perfect. Okay, not a problem there. So that works just right. And you probably look at the same thing on the bottom. You say, I'm going to find a common denominator so I can combine these. And I'm going to say, you know what? The common denominator is 20. So I'm going to multiply 4 over 4 here. And I'm going to multiply by 5 over 5 here. And so I end up getting 5 times 1 is 5 over 20 plus 1 times 4 is 4 over 20, and 5 plus 4 makes 9 over 20. Okay, now let's hold for there for a second. Now, you didn't do anything you couldn't because 3 over 3 is 1, 2 over 2 is 1, so I just multiplied all 4 of these by 1. But by finding these common denominators, it allowed me to combine these and have one fraction on top and one fraction on bottom. This is a good example of a complex fraction. Complex fraction is just a fraction with fractions in it. Now, you have to go right back here and think about what your 5th grade teacher told you, that in order to multiply fractions, you keep the first one, you change the division to multiplication, and you flip the second one. And so I end up with 5 over 6 times 20 over 9. Now, let's go to what we looked at last time, that I can reduce these. 20 and 6, they're both even. That makes a 3 and a 10. And this 5 doesn't cancel the 3 or the 9. Don't fall into a trap and try and reduce the 5 and the 10. They're both on the top. So I end up with 5 times 10, that's 50. Over 3 times 9 is 27. Okay, cool. So if you know a different way to do it, I'm going to show you a second way. But before we're looking at that, I want to look at this. And we're going to look at this the same way. So I'm going to find a common denominator in the top, a common denominator in the bottom. I'm going to multiply top things like this so I can make the denominators the same. And that will give me one fraction. Now, let me just zoom on this just a hair. There we go. Make it a little bit bigger. So x and 2x. Well, common denominator is 2x. And I can multiply this by 2 over 2. And that's going to give me 1 times 2 is 2 over 2x. And then I've got plus 1 over 2x, so plus 1 over 2x. Okay, I'm going to ignore the denominator for a second. I don't know why I'm still writing in red. So 2 over 2x plus 1 over 2x. That makes 2 plus 1 is 3 over 2x. Cool. So the whole point of doing all this is to combine these two fractions into one fraction. So goal met. Done. Here, 1 over 2y, 1 over y, I multiply by 2 over 2 to turn this into a 2y. So I end up with 1 over 2y plus 2 times 1 is 2 over 2y. And 1 plus 2 is 3 over 2y. Now, I think some of your first impulses might be, hey, I can cancel out the 3 with the 3 and the 2 with the 2, which you can. And then you're going to think, oh, it's x over y. But the problem with that is if you do that, it's not x over y. Let me show you what really happens. I'm going to take this 3 over 2x, and I'm going to multiply it by that flipped. So 2y over 3. Where'd the x go? 3 over 2x, 3. Oh, no, that's right. So 3 cancels 3, 2 cancels 2, and I end up with y over x. And that's it. See, if you cancel the 3 over the 2 and the 3 over 2, you're not left with x over y. You're left with 1 over x all over 1 over y, in which case you'd have to flip it there, okay? So be careful. There's my thing. Now, there is another way to look at that. Check this out. Let's go back to this very first problem, and I'm just going to copy it down here. 1/2 plus 1/3 all over 1/4 plus 1/5. Okay, and what you're going to do is you are going to multiply top and bottom by a common denominator. So I have to think, so I'm going to come off to the side and think, common denominator between 2, 3, 4, and 5. Here, 2, 3, 4, 5. Well, I see that 2 goes into 4. So, in other words, anything that has 4, 2 is going to go into. 3 and 4, well, 3 times 4 is 12, so 12 is a common factor, but 5 goes into 12. So if I go 3 times 4 times 5, I end up getting 60. There's my common denominator. So what I'm going to do is I'm going to distribute 60 through this whole thing. So 60 over 60. Now keep in mind, by multiplying by 60 over 60, I've multiplied by 1, which I can do without changing values. But what really happens here is every term gets multiplied by 60, okay, once I distribute that through. So let's think this. What's 60 times 1/2? Well, that's 30. What's 60 times 1/3? Well, that's 20. Now, if you can't do that in your head like that, just do this. 60 times 1 is 60, divided by 2 is 30. 60 divided by 3 is 20 times 1. So times by the top, multiplied by the bottom. 60 times 1 is 60, divided by 4 is 15, plus 60 divided by 5 is 12, and all of a sudden I end up with 50 over 27. See how it's the same? This is a legit way to do it. Now check out what happens on variables. I'm going to copy this problem down. 1 over x plus 1 over 2y all over 1 over 2y. That's not x. 1 over x, 1 over 2x, not 2y. Sorry, I'm going to get ahead of myself. Okay, and plus 1 over y. Okay, so again, I look at that and I'm going to go, So come off to the side over here. I need to find a common denominator between x and 2x and y and 2y. Well, x goes into 2x, so anything that has the 2x is going to be good. And y goes into 2y, so there's that. It's really tempting to go 2x times 2y and get 4xy, which would work. But it's easier to look and say, I need a 2, because that's one of the factors. So my common denominator has to have a 2. So the 2 is good, and that 2 is good. It's have an x, so that's good. And it has to have a y, so that's good. So there's my common denominator. So I'm going to multiply everything 1 by 2xy. So I multiply that, and that, and that, and that by 2xy. Now check out what happens here, guys. Here, the x cancels out the x, and I have 2 times y times 1. So 2y plus the 2x cancels that 2x, and I have 1 times y, 2y plus y. Well, 2y plus y is 3y. Okay. Here, 2 and y cancels the 2y, and I have x times 1. It gives me x plus the y cancels the y. 1 times 2x is 2x. And 2x plus 2x is 3x. Okay, the 3's cancel, and I just have y over x. Okay, so see, multiplying by that denominator can really streamline this process. Let's look at some other things. Okay. Check this out. Choose a method you would like to use and simplify. I'm always going to multiply by a common denominator. Now look at this. I've got x squared, x cubed, x4, x5, x6 is my common denominator. So I'm going to multiply everything here times x to the 6th. So I'm going to go x to the 6th x to the 6th, x to the 6th, x to the 6th, x to the 6th. And I know this is maybe a little crowded, but that's okay. Let me zoom in a little bit. So I multiplied everything there by x to the 6th. Check out what happens here. That cancels, and I just have the plus 1 here. These 5x's get canceled by 5 of those and leave me with 1 times x. That's just x. These 4 cancel out 4 here and leave me with 2. So I have x squared. Okay, now up here, this 1 cancels out 1, and I have x to the 5th. These 2 cancel out 2 here, and I have x to the 4th. These 3 cancel 3 here, and I've got x cubed. Okay? And that's it. That's all there is to it. See it? Isn't that cool? So let's look at this way. Let's look at this. Here's a complex fraction. I'm going to look at this and, here's this. I'm sorry. I'm going to multiply each thing by a common denominator. Now, here's where this can get a little bit messy if I'm covering this out, but the common denominator, I need an x minus 2, so x minus 2. So I'm jotting over here these pieces. I need a 2 times an x. Well, I don't have one of these, so I need a 2 times an x. I need an x squared. I don't have an x squared, but I have an x, so I just square it. See, I don't need a 2x and an x squared. That would make x cubed because x goes into x squared. And I need an x minus 2. I've already got one. So here's my common denominator. So I'm going to multiply. I'm going to multiply both of these by 2x squared times an x minus 2. Top and bottom. So I'm going to multiply by that. Cool. Now, check out what happens. Now, I can write this out piece by piece, but I think I can do this in my head. Because check it out. If I multiply this piece, well, maybe even I need to do this, like this, and here, and go 2x squared x minus 2. 2x squared x minus 2. Maybe that'll help me see it a little better. So if I multiply this here, the x minus 2 cancels out x minus 2, and I have 2 times 2x squared. Okay, here the 2x cancels out the 2 and one of the x's, and I have 1 times x minus 2. So plus 1 times x minus 2. So let me get this together first. That gives me 4x to the 2nd plus x squared minus 2x. Okay, which that can be combined into 5x squared. So I'm coming over here. 5x squared. So I had this times that. 5x squared. X. Okay. 5. Oh, minus 2x. I don't know what I'm thinking here. Minus 2x. Okay. And those are going to be over something. Now on the bottom, check this out. X squared cancels x squared, and I have 2 times 2. That's 4 times x minus 2. The 4 came from this 2 times that 2. Over here, x minus 2 wipes out x minus 2, and I have 1 times 2x squared, so plus 2x squared, which gives me, if I distribute this through, 4x minus 8 plus 2x squared, and that's just going to be it. 2x squared plus 4x minus 8. So there's what I got. Let me unsquish this thing. So I got 5x squared minus 2x on the top, all over 2x squared plus 4x plus minus 8 plus 4x minus 8. Okay, there we go. Now, check this out. This looks ugly for a moment. Whew, It just looks ugly. Sorry, guys, I'm yawning. But this is a complex fraction because x to the negative 2, that's just 1 over x squared. Plus y to the negative 2, that's 1 over y squared. And those are being added. And this is 1 over x plus 1 over y. Okay, so let's simplify that. Well, common denominator is going to be x squared times y squared. So I'm going to multiply everything by x squared y squared. X squared y squared, x squared y squared. And check it out. X squared cancels x squared, and I have 1 times y squared. That gives me y squared. Here, y squared cancels y squared, and I have plus 1 times x squared. So that's just plus x squared. On the bottom, x wipes out one of these, and so I have x times y squared. X, y squared. Here, y wipes out one of these, and I have x squared y. And there it is. And that's done. I'm done. I can't do anything. Okay? That's it. Now. I'm going to skip number 7 for a second. And I want to look at some of these. These 4 problems, I'm going to let you guys work these ones out if you want. But these 4 problems here are all taken off of old midterms and or old finals. So let's look at them one by one. Now, this first one is a little bit unique because it's 1 fraction over 1 fraction. So the very first way we looked at it was trying to combine them and get 1 fraction over 1 fraction like here. Well, it's already here. So I'm not going to bother to find common denominators. All I'm going to do is I'm going to take this 2x cubed over 3y and multiply it times this second one flipped. So 6y over x squared. Okay? Now, the x squared cancels one of these and leaves me with x to the first. The y cancels out the y. And this 3 underneath the 6 reduces to a 2. And so everything's gone off the bottom. And all I'm left with is 2 times x to the first times 2 times 2. So 2 times 2 is 4. And this x to the first is just 4x. And that's it. That's all there is to it. Okay? Let's look at this second one. Number 9. So I've got denominators a, 5, a squared, and 4. Well, a and a squared, that's going to give me an a squared. 4 and 5, that's going to be 20. So I'm going to multiply everything here by 20 a squared. 20 a squared. 20 a squared and 20 a squared. Okay, now check out what happens. Here, a squared wipes out a squared, and I just get 20 times 3, that's 60. Here, 20 divided by 4 gives me a 5, and I have minus a times 5a squared. Well, that's a negative a times 5a squared, which is negative 5a cubed. Okay. Now, on the top, this a gets canceled by one of these, and I have 20a times 12. Okay, 20 times 12. What's 20 times 12? 20 times 240. So I've got 240a plus 20 divided by 5, that's 4. And a squared times 4a squared is plus 4a to the 4th. Okay? Now, I'm looking at this. Common factor here is a, but there's not an a down here. Common factor between here is 5, but it can't get 5 out there. So this, right now, is done. It's as good as it can get. Okay, let's look at one more. over here. Well, 2 more. So I've got this 1 plus 1 over y all over 1 minus y squared. Common denominator, well, there's none, y squared. Common denominator is y squared. So I'm going to multiply both sides, top and bottom, by y squared. So I end up getting 1 times y squared. That's y squared. Plus y squared. So this y cancels out one of those. So y squared plus y. And here, 1 times y squared, that's just y squared. Minus y squareds cancel, and I get 1. Okay, now, here's what happened. These are both factorable. This has a common factor of y. So I have y times y plus 1. And then this is a difference of squares. This factors into y plus 1 times y minus 1. These cancel, and I end up getting y over y minus 1. You always must consider, can I simplify my answer? Okay? Now, let's look at this last thing. I've got a plus 5 and this. Now this is a squared minus 25. That's a difference of squares. The pattern is a plus 5, a minus 5. And all of these go into that. So I'm actually going to multiply everything by a plus 5, a minus 5. And I'll do there a plus 5, a minus 5. Now check out what happens. Here, that totally cancels, and I get minus 1. Here, the a plus 5 cancels that a plus 5, and I get 1 times a minus 5. On the bottom, a minus 5 cancels a minus 5, and I get 4 times a plus 5. Let's distribute that. 4 times a is 4a. 4 times positive 5 is positive 20. And this, a plus 5, wipes out a plus 5. Wait a second. Here, I'm just looking. Here, I canceled the a minus 5. And I had this. Here, I canceled the a plus 5. And I'm left with the minus 5. So plus 5 times a. And plus 5 times a negative 5 is negative 5. Combining my like terms, I end up with a minus 6 on the top. And on the bottom, 4a plus 5a, that's 9a. And 20 minus 5, that's plus 15. And that's it. I'm not going to factor it. Sorry, guys. Left out. I'm not going to factor it. And I'm not going to factor it because there's nothing that will give me an a minus 6. So that's it. Guys, that is complex fractions. Your homework is going to walk you through some of these problems. I don't care which way you do it, or if there's another way that I don't quite see. But that's it. Work on practice. This is something you need to practice. Guys, there has been one of these kind of questions on every single midterm that has ever been given. I fully expect there to be something here. And in fact, there's 4 of them. 8, 9, 10, and 11 are 4 problems taken off of old midterms. So work through those. That's the level you need to get to. And I shall see you when I see you. Have a good one. Bye. Bye.